Hello, calculus fans. So let's let R be the first quadrant region under the curve y equals 2x squared between x equals 0 and x equals 5. We're going to take this region and revolve it about the x-axis to generate the solid. And then our problem is going to be to find the volume of this solid. Let's take a look at a picture. Okay, so we got our curve y equals 2x squared. We want the first quadrant region between x equals 0 and x equals 5. We revolve this about the x-axis to generate a solid. Notice that we're going to slice this thing perpendicular to the x-axis, and after this thing is revolved about the x-axis, it generates a solid, and so the slices are going to be disks. So what we need is to figure out the volume of a disk. So delta V is pi times the radius squared times the thickness, because a disk is just a very squat cylinder. So in this case, it's pi times y squared times delta x. Y is going to be the radius of the cylinder, because in the picture, the radius is the little piece that you saw that I had sketched, the little slice, and so that represents a radius, and that distance is just a y distance. And of course, y is just equal to 2x squared, so we can replace that in there. So really our delta V is pi times the quantity 2x squared, quantity squared, times delta x. We put that in an integral now. We integrate from 0 to 5, and we integrate pi times 2x squared quantity squared dx. So we get a 4 pi that we can pull out in front, because when we square that 2, we get a 4. And then the x squared squared turns into x to the 4th. Alright, this is actually a very easy antiderivative. We get 4 pi times x to the 5th over 5, evaluated from 0 to 5. It's nice when we plug in the 0, we get nothing. So we get 4 pi times 5 to the 4th power. So our final answer is 2500 pi, and that's the volume of the object that we've created. Okay, that's all for now.